So this video is the second part of the Newton forces practice problem for the midterm. As you can see, there are an Atwood machine which is pulling two different systems, so which is what we call two body. One of them will be involved with the friction and incline, the other one will not. So the one on the left is very easy compared to the one on the right. And there is actually another one, but that one I already made another video, and you can go to the hub and look at the previous example. So for this one, let's go ahead and look at the types of questions that you're going to be solving for. So basically, just look at what the question is asking. So let's go back to that question, which is the diagram on the left. So the question says two masses attached to a frictionless massless pulley. The mass of block A, which is 5 kilograms, and the mass of block B is 2 kilograms. So we're going to have to label which one is mass A, which one is mass B, based on the picture. I hope that's not too hard to determine. One of them has a mass of 5 kilograms, the other one has a mass of 2 kilograms. So I'm just going to go ahead and label this one as an A and this one as an B, because A has greater mass than B. So now go ahead and look at the question is looking for the acceleration of the system when the blocks are released, and what is the tension. So this one is a little bit more complicated, because you cannot just find the acceleration by itself. You have to take into consideration of two body diagram which is attached to one another. So I'm just going to go ahead and draw a free body diagram which involves all the forces. Box A, we have the mass due to the gravity G, and there is another force of tension there. And block B also has a force of tension, and block B mass gravity, which is the weight of block B. So now with this one, we're going to have to take into consideration which direction will the boxes move. So this one is obviously, since this one is greater than mass B, and it will go that way. So if it goes that way, we can take it into consideration. Okay, for this one, we're going to go ahead and take this one. I'm just going to say 1 is equal to M, 1A. A, how about that? Okay. Sum of the forces involved, box A is equal to mass A times acceleration A. So M AG minus force of tension is equal to mass A times acceleration. That's the first equation you need to know. And now we're taking consideration of box B only. Sum of the forces in B is equal to mass B times accelerations, okay? Since the box is moving up, the box is being lifted up. So that means that the tension has to be greater than mass BG is equal to MEA. So now what I'm doing is I'm isolating the T by itself. So what I have to do is I will add MBG both sides of the equation. And that should give me tension is equal to MBA plus MBG, right? And that is tension equation. So now I'm just going to go ahead and substitute into the first equation. This is second. So what that means is that I'm going to go ahead and write it down. MA gravity minus T, which is MB acceleration, plus mass B times gravity, which is the weight of mass B, is equal to mass A times A. And these are the final equation that we need to have. So now, since we're looking for acceleration, so we need to combine this term. So what I'm doing is that I'm putting MAA there and plus MBA because I moved this one over there, or basically I'm adding MBA both sides of the equation to get rid of the MBA here. So on my left side of the equation I have the weight of block A plus the weight of block B is equal to MA times the mass of block B and A. So I'm isolating MA plus MB to calculate that. So my final equation to calculate for the acceleration would be this. And since I'm looking for acceleration, so therefore I'm just isolating that. So basically I do this. I'll multiply both sides of the equation. So plus mass B. And that would be the equation for you to solve for the acceleration of this block right here, of the two boxes in. Once you get the acceleration, then you plug into this equation. Either these are the equation to find the tension. Let's pause per minute for you to actually absorb what's actually going on into that system. I'm just gonna go ahead and take those on this one right here. Substitute A in either equation 1 or 2. To get force of tensions. Either or you will get it. So now we're gonna go ahead and take into consideration for the next round, which is the one on the right. So the one on the right is a little bit more complicated because it involves more forces, including friction. For this question, I'm just going to go ahead and ask that you actually try to do it first and discuss this as a class to see what you come up with, because they involve more process, and I'm just going to go ahead and help you one-on-one with these types of questions, okay? Okay, let me go ahead and do this question right now real quick, real fast, so that you will get an idea of what's going on. So I'm just going to go ahead and do this one, so it will be M2G, and I have a force of tension there. For this one, since I have mg, right, I'm just going to have to separate the vectors. M2 is m1g. So I have to make a vector into the x and the y direction. So that will be normal force. This will be mg cosine angle. So that will be mg sine angle also. Since the box is moving upwards, there is another tension. Force of tension there. Let's put it into a color coordinator. In the x direction, I'll put this one right here. So I have two different forces, which is force due to the tension moving it up, and I have the force due to the weight trying to counteract the forces going that way. And since I have the frictions, so the friction is trying to slow it down. Since the box is moving this way, so the friction is going that way in the opposite directions. Okay, let's confirm which one has more mass. Of course, M2 has more mass, just like what that one is. So it goes this way, the friction is going that way. So, force of friction. So we have three different forces in the x direction and have two different forces in the y direction. So let's take into consideration for the block that is hanging. So I'm just gonna say sigma force of hanging is equal to MA. Thank you. So see, it goes this way, right? So it's gonna be M2G minus force of tension is equal to M2A. That's one of the first equations that I have. Let's make it easy, simple. So my tension will be equal to is this minus M2A. That's the force of tension that I'm gonna have to substitute into that equations. So for this one, we're gonna go ahead and have to actually in the y direction first to figure out the normal forces. So that would be normal forces minus mg cosine theta is equal to 0. So normal force is equal to mass cosine theta. That's your normal forces. And then now we're going to go ahead and look into take into consideration for the sigma fx is equal to 0. How many forces are in the fx? 3. So I'm going to go ahead and do this one right here. T minus mg sine minus mu n equal to ma, m2a. We have to fix this one because they're not in the static equilibrium, they're moving. But in the y direction, it is in the static equilibrium because the box is not moving up and down or vertically above the incline. And now we are tasked to calculate for the acceleration and tension. So for this one, we're going to have to substitute what the t is onto this equation in order for us to mass A, in order for us to calculate the acceleration in the x direction. So I'm just going to go ahead and put in m2g minus m2a as t. And then minus, I'm putting down the same. Minus mu, what's my n? My n is kind of mg cosine theta is equal to mass times accelerations. So if I have to figure out what acceleration is, I will divide the mass both sides. Equation to figure out acceleration, then I will substitute A in to this equation in equation 1 to get force of tension. So now it's going to be your turn to plug in the number on all the values to get all the information you needed.